Um, if you go to the course website, guys, if you go to the course website, this is the course website. It contains everything that you need to know about this course, and this includes the videos, like the videos after every session, whether it is a review session or whether it is a tutorial. You will see the videos appearing in this. Like for example, the videos for the review session yesterday are this and this one, right? And the video for the tutorials yesterday are this one and this one, and the video for the tutorial this morning this one and this one. All right, so you can see the videos appearing soon after the sessions every day, every time. Okay, I don't put videos in the Blackboard. I mean, I don't like using Blackboard, so I put all the videos in this website, right? Which is, this is the URL. I think I showed you this before. This is the URL for this website. Okay. All right. So please, if you want to see a particular video, just visit this website and find out where it is. Right. All right, guys. All right. The next thing is about today. I mean, today I'm going to go through this. I'm going to go through this tutorial sheet. This one, right? Which is introduction to R. R, as you know, is a statistical software. It's a free statistical software, right? So I'm going to show you how to. I'm going to go through line by line and show you how to do things, right? All right. Okay. Now, if you have any questions during the session, you can use the chat box, right? You're most welcome to use the chat box. Any questions you guys have, please feel free to use the chat box. Right. Now, the first thing I want to show you is how to install R. Right. So to install R, what you need to do is the following. Just open a browser. I will use my Google Chrome, right? And then you type the following. You type www.r-project.org, and you will come to this page. Now here you click on download R, it will take you to this page. And this is a list of mirror websites. So for different countries, there are websites. So since I'm in the UK, I will go here and click here, right? Now you will get to this page. You see there are 3 links. There are 3 links, one for Linux, one for Mac, and one for Windows. So depending on the operating system that you have, you choose the appropriate one. I have Windows. I'll click here. All right. Then if you're installing R for the first time, you will click here, right, and go through a number of steps, and that will install R in your computer, right? Now I have already installed it, so I don't need to do anything because I already have R in my computer, right? Okay, so let me close this. Now once you install R, you go into this start button, and then you go down. Excuse me. Sorry, I'm doing something stupid. You go down this path, and then you choose R. Right, you click on R. You see there are 2 options here. One is 386, the other one is 64. So you will choose the 64 one because that is more powerful, and it will come up with this window. So this is the R command window. All right, guys, this is the R command window that you need. You can type your commands Now I will show you how to do things. I will show you how to do things. All right. So, for example, the first thing I want to show you is how to use the help. Like, suppose you want to find help on a particular command in R. Say, for example, plot. Right. Plot is a command in R. Right. Okay. So if you say help in brackets plot, it will tell you how to use the command plot, right? Right. So anything you need help with, just type help in brackets, the name of the command that you need help with, right? Now, if you want to add two numbers in R, you just use this command. Like if you want to add two numbers, 33 and 24, you just say 33, 24, right? If you want to add and subtract, this is what you do. If you want to multiply two numbers, this is what you do. If you want to divide two numbers, this is what you do, right? And if you want exponentiation, this is what you will do, right? For exponentiation, you just say 4 power 3. 4 raised to the power 3 is equal to 64. Okay. Now, if you want something more complex, like this, for example, right? Here, the order of operation is first multiplication, then division, and then addition, right? So it's multiplication first, then division, and then addition, right? Now, pi is a number, excuse me, pi, oh man, what happened? Pi is a number in R, and it takes the value 3.141593, right? I'm sure all of you know what pi is, right? So if you want to if you want to multiply pi by, say, 10 to the power 2, this is what you will get. All right. All right. Next thing. Now, how do you create objects in R? Like, suppose you want to create an object that contains the value 23. Then A, excuse me, this is the command that you will use. So it's A, backward arrow, then 23. So what this means is that the value of 23 is assigned to the object called A. And similarly, if you do this, you will have a value of 5 is assigned to the object called B, right? Exponentiation happens before, yeah. You're right, Simon, yeah. The exponentiation happens before multiplication. Yeah. All right, now suppose you want to multiply two numbers, A and B, then you will get this. Division, you get, so A times B is 115, A divided by B is 4.6. Then you can create a new object. You can create a new object, say C, which contains the value 10 times A times B, then C will be this, right? Okay. Right, now if you type ls, the command ls means it lists all objects in R. So ls stands for list. So it lists all the objects that you created so far, so you created 3 objects, A, B, and C. By the way, the number key here, the number key is a command line. It's a, like for example, this is a command line. So anything that you write after the number key is a comment, right? The division and multiplication does not matter which order it comes. You can have division first and then multiplication, or multiplication first and then division. It doesn't really matter. It doesn't matter whether you have multiplication first or division first. All right. Okay. Right. Okay. Now the command rm. The command rm means remove. So rm stands for, it removes all objects in R. So this command here removes the objects A, B, and C from R. So you should not type ls. There are nothing left in R, right? As you can see, right? Okay, all right, guys. Yeah, both of them are the same, Adam. So whatever you entered is the same. I mean, they give you the same answer. All right. Anyway, let me continue with my session so far. Right now, suppose you give the value 5 to an object called x, right? Okay. So now you should type capital X, then it will give you an error message. The reason for that is because the little x and capital X are two different things in R. So case matters, like whether it's a small letter or capital letter does make a difference in R. Okay. Now the next thing I want to talk about is how to create vectors. Now suppose this command here, little c open bracket close bracket, creates a vector. So when you type, suppose you type this, right? Then what you have here is a raw vector of length 9 that contains these values, right? Okay, so that's how you create a vectors. To create a vector, you just put, say, c, little c, open bracket, then the numbers, then close bracket. Now you can do any standard operation with the vector. So 2 times x, it multiplies every element by 2. 2 times x plus 1, it multiplies every element by 2 and then adds 1. 1 divided by x is a reciprocal of every number in x, right? Now there are certain operations there are certain operations that you can perform on vectors. So for example, length of x is how many data points that you have in x, right? So there are 9 data points in x, as you can see, right? And sort of x, what it does is it arranges the data from the smallest value to the largest value. So 1.4 is the smallest and 16 is the largest, right? Now, square root of x. So what it does, it takes the square root of every element in x, right? Then mean of x computes the average. It computes the average value of all the values in x, right? Var of x computes the sample variance of all the values in x using the formula that I gave you yesterday in the review session, right? The unbiased version. Remember, I gave you 2 formulas for the sample variance, and this version here, it computes the sample variance using the unbiased formula, right? SD of x is the standard deviation of x. You can also compute the standard deviation by taking the square root of the variance. So you see both these commands, they give you the same answer as they should, right? Okay. Now if you type ls, you will see we have just one object x, right? Now, next thing is how to access, like, let me retype x, all right? Let me show you how to access a certain element of x. Suppose you want to access the third element of x, which is 4.9, right? Then you just type x in brackets 3. It returns the third element, which is 4.9, right? Now, suppose you type this. If you type this, what it does is it removes the third element. So you see what happened here. This is the same as this vector here, but the third element has been removed, right? Okay. Yeah, you're right, Harry. So ls stands for list. I think I mentioned that to you guys before. If you go up, guys, here, I mentioned this here. It lists all objects in R. Yeah. Okay. Okay, x, so x in brackets -3, what it does is it removes the third element from the vector. So you get this as the vector, right? And if you type x this, right? So let me retype x, and if you type x like this, right? What it does is it lists all the elements from the second position to the 5th position. So it's all the numbers from 2.7 to 7.8. Yeah. Okay. Next, now you should type the following. If you type the following, you will see it lists all the data points at the 2nd, 4th, and the 8th positions. So if you look at X here, this is the 2nd data point, this is the 4th data point, and this is the 8th data point. So it lists 2.7, 5.5, and 15. Okay. And now you should type like this. What this does is it lists all the values in X that are greater than 12. So it basically, these 3 values are the values which are greater than 12, right? Now, if you type this, right? What it does is it lists the values in X which are less than 2 or greater than 15. Here, let me say this, excuse me, this means O. Okay, so the vertical sign here means O, right? So you're looking for the values in X which are less than 2 or greater than 15. So there are only 2 values that satisfy these two. So one, this or this, that is 1.4 or 16, right? Now, if you type X greater than 6 and less than 12, right? This is what you will get, because I mean here by the, okay, let me explain. This means and. Whenever we use the sign, this sign here, it means and. So you're looking for all values in X. You're looking for all values in X which are greater than 6 and less than 12. So it's basically 7.8 and 4.2, right? Okay, guys. So this vertical sign means O, and this sign here means and, right? Okay. Yes, you are right, Dala. Yeah, this means this. Yeah, that is like I don't know if you can. I don't know. Maybe my camera is not good, but this means the and symbol in the keyboard. Yeah, yeah. All right. Now, next thing I'm going to talk about is logical vectors. Now, if you type X greater than 5, it gives you either true or false. That's because what it does is it checks whether each data point is greater than 5 or not. 1.4 is not, 2.7 is 4.9 is not, but the remaining elements are greater than 5. So the first three are false. The first three are false, and the remaining are true, right? Okay. So now you should assign this to an object called LV. Then LV will contain these values. LV is just an object, right? Right. Now, let me okay, let me retype x greater than 5, right, which is this, right? Now there is a huge difference between this command here, right, and this command here, right? You see the difference between these two. In the first command, you have either true or false, depending on whether the condition is satisfied or not. Now in the second command, which is this one, right, what you have is the values in x such that x is greater than 5. So these are all values in this vector that satisfy the condition that x is greater than 5. So these two, although they look similar, they give two different outputs, right? They give really two different outputs. Yes, Harvey, you are right. Yeah, I mean, you can say x equal to 5 instead of x this 5. Yeah, both of them are acceptable. Yeah, but traditionally people use this notation. They prefer to use this to this. I mean, both commands they mean the same thing, Harvey. Yeah. Okay. Right now, before I go ahead, let me list all possible operations. LV is just a notation. I mean, it's just a name for an object. You can call it whatever you like, Sonia. I mean, I just call it LV because just wanted to give a name. I mean, you can call it, for example, you can call it Sonia, for example, or some other name, right? Okay, all right. Okay, now before I go ahead, let me list all possible operations. So this operation means less than, right? And this operation means greater than. I'm sure all of you know this. Greater than, right? And this means less than or equal to, right? And this operation means greater than or equal to, right? And double equal means equal to. Okay, and this one I have already said. This means and. All right. Okay, and the vertical sign. Hi. It means or. All right, and this one means negation, opposite of, right? Right. So these are the operations that you need to be familiar with if you're working in R, right? I mean, they're not hard to remember. Okay. All right. So next thing is okay. Let me show you how to do Boolean operations in R. I'm sure you've done Boolean algebra. Okay. So suppose C1 is a vector that contains a vector of length 2 contains true and true, right? Suppose C2 is a vector that contains true and false, right? Now you should type C1 and C2. Okay, I will give you the, yeah, Simon, I will do that in a minute. Give me a sec, okay? Now you should type C1 and C2, you will get true and false. That is because true and true is true and true and false is false. I'm sure you know that from from your Boolean. I'm sure you guys have done Boolean algebra in your some time ago. Now, if you say C1 or C2, right, then you get true and true. That's because true or true is true, true or false is also true. Now, if you type exclamation mark C1, you will get false and false, because the negation of true is false, the negation of true is also false. Now, if you type exclamation C2, you will get this, because the negation of true is false, the negation of false is true. All right, you guys follow me? Yeah. So that's how you use the exclamation mark. So the exclamation mark, it gives you the negation, opposite of anything that follows it, right? Okay, right. All right, guys. Now, let me, do you get that, Simon? I hope it is okay now. I hope you, is there an imply command? Imply, what do you mean by imply? I don't understand. I don't understand what you mean, John. What do you mean by imply? No, I don't think there is an imply command in R. I don't think so. No, I haven't seen an imply command. No, I don't think there is an imply command in R. Anyway, I may be wrong, but I don't think there is one. Anyway, let's go back to the sheet, right? Let's go back to the sheet, and there are two exercises that we need to do. This is exercise 1, this is exercise 2. So exercise 1, you have two vectors and you need to do all these manipulations, right? So let's start with exercise 1, right? Exercise 1, so the first thing you need to do is to create these vectors. Y contains the value, okay, and Z contains the value, right? So this is your Y and this is your Z, right? Now the first part is to compute Y minus 3, which is easy. So it takes away 3 from each element of Y. The second part is to multiply every element of Z with 3 and then add 1. So you get this. The third part is to find the median of Y. Remember, the median of Y is simply the middle number that the middle number, you should order the data from the smallest to the largest, right? And the median of Z is the same thing. If you order the data from the smallest to the largest, then you get the median, right? All right. Then sum. All right. What this does is it sums all the values in Z which are greater than 10. So it's basically a sum of 15 and 18, right? Which is 33, as you know, right? Now, the next one is mean of the values in Y from the second to the fourth position. So if you type Y, the second data is 2, the fourth data is 12. So it computes the average of these three values, right, which is 6, right? Next, the next one is the mean of Z, excluding the data from the fourth to the sixth positions. So if you type that here and if you exclude all the data from 4 to the 6th, that means these 3. So if you remove these 3 data points, right, and take the mean of the remaining, you will get it to be equal to 5. Yeah, that's what it says. Okay. And then Y plus Z. Y plus Z is undefined. That's because Y and Z are of different length. So Y and Z are vectors of different length. So I'm sure all of you know that you cannot add two vectors that are of different length. So y plus z is undefined. All right. All right. Next is sum of y greater than or equal to 4. Now what what this does is it computes how many of the elements in y are greater than or equal to 4. Basically, only these three, the last three elements in y are greater than or equal to 4. So that is equal to 3, right? Whereas the same command, if you put it like this, if you type it like this, guys, you will get this to be 32. The reason for that is because here you are taking the sum of the y's which are greater than or equal to 4. So it's basically the sum of 4 plus 12 plus 16 is equal to 32. Whereas here, over here, what you have is the number of elements in y which are greater than or equal to 4, which is 3. Here is the sum of the elements in y that are greater than or equal to 4. So these are two different commands. I mean, I think I mentioned this before. These are two different commands, right? So just bear with me, guys. Don't just quit yet. So I mean, we have time. We just only have. Now, if you type this, right, you will get um, the number of elements in Z that are greater than 5 and less than 12. Right? So that means there are only two elements. There are only two data points that are greater than 5 and less than 12, namely 8 and 9. Right? Okay. Right. So that completes exercise 1. Exercise 2. Exercise 2 is like this. Exercise 2. Now, you should go back to the course website. This is, let me show you exercise 2. This is exercise 2, guys, right? Excuse me. So you have this data set, right, which are closing prices, right, in 12 days. The first part is to enter the data into R. The second part is to find the minimum, maximum, range, mean, and the standard deviation, and so on. All right, so let's see how we can do it. So the first thing I'm going to do is I'm going to enter the data. So I would use this command, which I mentioned to you before, right? C, open bracket, close bracket. Excuse me, this is 43, 46, 48, 52, 54, 50, 47, 48, 48. All right, Joe, just a minute. All right, let me explain one more time, Joe. The difference between this command and this command is the following, right? Over here, what you're computing is the number of elements in y that are greater than or equal to 4, which is 3, because you have 4, 12, and 16. Those are the values in y that are greater than or equal to 4, right? And over here, what you're doing is the sum of the elements in y that are greater than or equal to 4, which is 4 plus 12 plus 16, which is 32. So you see the difference between this command and this command. Here, you're computing how many of the y's are greater than or equal to 4, and here you're looking for the sum of the elements of y that are greater than or equal to 4, right? All right, let me know if other guys are not clear, please let me know, right? All right, so we read the data into S. Now the next thing we want to find is the minimum. To find the minimum, you just type min of S. To find the maximum, you just type max of S. To find the range, remember the range is the difference between the maximum and the minimum, right? And to find the mean, you type mean of S, right? And to find the standard deviation, you type SD of S. All right, so that completes the second part. Now the third part, it says that the first data point, which is 38, should have been 48. So the thing is, how do you change 38 to 48? The simple way to do that is as follows, right? Remember, S1 denotes the first data point, right? So we want to change that to 48. Okay, now if you type S, you see that the first data has been changed from 38 to 48, right? Okay, now that's the third part. Now the fourth part is to find the percentage of days when the closing price was less than 45 pence. Now, first thing you need to do is you need to figure out how many of the data points are less than 45. You see, there are three. There are three data points that are less than 45. Then you compute the length of this, right? Which is 3, and then you divide that by the length of S, and then you multiply by 100. So 25 is the percentage of days, when the closing price was less than 25. So you see what I've done. I computed the number of days when the closing price was less than 45 and divide that by the total number of days, which is 12, and then multiplied by 100, right? So that gives you the answer for part 4. And part 5 is to use the diff command. Remember, S is this. Now, if you type diff of S, you will get this. So what diff does is the diff basically computes the successive differences between consecutive values of S. So 42 minus 48 is -6, 44 minus 42 is 2, 43 minus 44 is -1, and so on, right? The length of diff is always 1 less than the length of the original data. So actually, you should type length of diff, it is 11, whereas the length of S is 12. So it's always 1 less than the original data set. That's because of the way you compute the differences. You're doing it between successive consecutive pairs data, right? So the length is always 1 less than the original, right? So that completes exercise 2, right? The next thing I want to talk about, any questions so far, guys? Am I going too fast or what? Is it okay or too fast or too slow? Let me know. All right. It doesn't matter. It doesn't matter whether you put spaces or not. Yeah. It doesn't really matter. I will try to slow down, yeah, in the future. But question is, yeah, I mean, whether you use open brackets or square brackets, I mean, it depends on the kind of command. Like normally, like when you use a command like for example, length, you use open brackets. Like whereas if you want to compute like a certain element of S, then you use close bracket, right? So like S close bracket 2 computes the second data point in S. Whereas if you have a command like say sum of S, you need to use open brackets. You know, you see the difference between, sometimes you use open brackets, sometimes you use sometimes you use square brackets. The square brackets are usually to pick out a certain element in the data, like the second element, third element, or the fourth element, right? You can pick out a certain element in the data. whereas you use the open brackets when to issue a command, right? To do a command in, right? Anyway, I will try to slow down in the future, but and the reason I was going fast is we need to, like, we only have 1 hour left. So all right, the next thing I'm going to show you is how to read data. Now, if I go back to the website, this is I'm going to show you how to. There's a command called read table. You can use this command to read a table, to read data from a file. So if I go back to the course website, this is a data set here, and this data contains what time running times for a certain number of people in seconds, right? So suppose I want to read this data. So what I do is I copy this URL, right? And then paste it here, and then put that in double quotes, and then I say read dot table, open bracket, then say header equal to true. I need to say header equal to true, because if you go back to the data set, you see the data set has a header which is called time, right? So we need to say that the data set has a header. So that's why I'm saying, like, when I read it, you need to say header equal to true, right? Now let me call this data set Moses, right? All right, and once you read it, you will get this. You see, this is the data set that you get. The first column is just a counter column, which you can ignore. The second column is the actual data that you read, which is called time. Now, if you want to access this column, what you do is Moses dollar and the name of the column, which is times. So this is the variable that contains the data, right? So if you want to compute the summary statistics, of the data, like for example the minimum, right? So you say min, open bracket, close bracket, that computes the minimum, right? And if you want the maximum, you do this, right? If you want the mean, you do this, right? If you want the median, you do this, right? Right. So every time I'm using the open brackets here, because I'm giving a command, right? So whenever you give a command like extract a certain value or certain values, you use open brackets, right? Now close brackets. Now suppose you want to find say a proportion of values in Moses in the time, right, that are less than say 47.5. So in this case, you will use square brackets, because you're looking for values in Moses dollar time which are less than 47.5, right? So here, then you will take the length of this, and divide by the length of Moses dollar time. Now, what this command tells you is the proportion of the data that are less than 47.5 seconds, right? That's one of the questions here, is the proportion of the data which are less than 47.5 seconds. So what I've done is to use the square brackets to extract part of the data that is less than 47.5, right? And then find the length of that data, and then divide by the total length of the data, right? So that gives you the proportion. Now, if you want to find Okay, give me a sec, Sonia, just a minute. If you want to find the proportion where the time was greater than 49.5, you will issue this command. Sonia, are you okay now? Is this the part you wanted to know or not? Okay, good. I mean, I'm recording this session, so you'll be able to view this later on. I mean, I record, as I said before, I record every session, whether it's a review session or tutorial session, I'm recording everything. So after a while, you will be able to see a video of this on the course website. Okay, all right. The next thing I'm going to talk about is categorical data. Let me see what the time is now. Let me, excuse me. We have a few minutes left. Okay. The next thing I'm going to talk about is categorical data. Categorical data is typically like if somebody asks you whether you drive a car or not, it can be either yes or no, right? Or if somebody asks people like whether they smoke or not, it can be either yes or no, right? So those are examples of categorical data. So let me type this vector here. Just be patient with me, guys. Mm. All right, so what you have here is a list of yes and no's, right? Okay, now if you want to summarize the categorical data, you can use the table command. So for example, so in over here, it tells you that there are 8 no's and 7 yeses. So 8 people said no, and 7 people said yes, right? Now, if you want to convert a categorical data into a factor, you can use this command. A factor is a variable that takes a finite number of levels, right? So you can find the levels of a factor using this command. Um, um, so the levels of this factor contains either yes or no, right? Or no or yes. Now, so you can convert, like suppose you don't like dealing with yes or no, or you want to call it something else. Like for example, suppose you want to call um, no 0 as corresponding to no and 1 as corresponding to yes. Then you can issue this command here. So this command, what it will do is it will record no as being 0 and yes as being 1, right? So now if you retype response F, you will see the data recorded as 1 and 0. So yes is coded as 1 and no is coded as 0, right? Okay, so that's on categorical data. And finally, if I have time, let me go back to the website and click on the sheet. I will do the final exercise, which is this one, the last page. So in this exercise, what you're asked to do is the following. You are asked to read this data set, and which is a data set on party. Is coded as either 1, 2, 3, or 5. So 1, 2, 3, 4, or 5 for 5 different parties. Now, the purpose of this exercise is to record the data in terms of the actual names of the parties. I will show you how to do that in a minute. So just bear with me. I might have run out of time already, but just give me a sec, okay? So what you do is, the first thing you need to do is Factor is just, it converts the categorical data into a factor variable that takes a finite number of levels, Simon. So like factor in the case of yes and no, it converts the yes and no data into a factor with 2 levels, right? And the factor is very useful because you can use it to, you can use a factor variable and record the levels as you wish. Like here, for example, I use this command to record the levels in the factor as being 0 and 1 instead of being no and yes. I call it 0 and 1, right? Okay, now, okay, I just read the poll data, and if you look at it, it has 2 columns. The first column you can pretty much ignore. I hope you got it, Simon. Yeah. The first column is just counter variable. The second column is the party, 1, 2, 3, 4, or 5, right? So if you type poll $party, it gives you the numbers 1 to 5, right? So 1 to 5 correspond to 5 different parties. Now, if you want to record this as something actually meaningful, you need to first convert the data into a factor, right? So this command will convert the data into a factor. And then if you look at the levels of poll F, you see it has these 5 numbers, 1 to 5. Now, suppose I want to record the levels. Instead of calling it 1 to 5, I want to call it actual party names. So 1 corresponds to the Conservative Party. 2 corresponds to the Labour Party, right? And 3 corresponds to the Liberal Democrats Party. The 4 corresponds to the UKIP Party, and the 5 corresponds to other parties, right? Okay. Now, if you type poll F now, what you will get is this. You see, the data has been recorded in terms of the actual names of the parties than just the numbers, right? All right, now if you type table poll F, you will get this. So this is a summary of the data. So you can see there are 369 votes for Conservative, 314 for Labour, 75 for Liberal Democrats, 118 for UKIP, and 124 for other. All right, so you see the factor is a very useful command because it allows you to record the data as you wish, right? Instead of calling it 1 to 5, you can call it some other thing like what I did here. All right, guys, any questions? So this is the end of the tutorial sheets. I hope you found something useful out of this. Let me know if you have any questions now. Or are you okay? The back arrow actually means it's just a assign. It's just a assign. It's an assignment operation, guys. All right. Yeah, you can do the sheets in your own time. Yeah, that's good. You can do the sheets in your own time, and you can look at the videos of the tutorial and see what you've done is correct or not. Okay. All right, guys. Enjoy your time. Enjoy your afternoon or evening. I'll talk to you later soon. Right, and please feel free to contact me 24/7 for any questions you guys have. Right. Bye.
Thank you.
Thank you.